All right, here we go. Time to look at equations with decimals. Now, we just finished a chapter where we were solving equations with whole numbers. This is no different, except there's just a little decimal point in there. Not a big deal. The process is the same. We're still going to use the inverse operations. That means if it wants us to add, we'll subtract. If it wants us to multiply, we'll divide, so on and so forth. All right. Nothing really new to teacher, so let's just get into some examples and how you would solve these. All right, so let's take the first one, W minus 147 and 67 hundredths. We're going to say that's going to equal 144 and 67 hundredths. All right, so what is this wanting us to do? It wants us to take W minus 147 and 67 hundredths. Well, we're going to do the inverse of that. If it wants us to subtract, we're going to add. And we're going to add 147 and 67 hundredths. And what that does is it ends up canceling out these two terms. So therefore, we're only left with the W on this side. So that's called isolating the variable. Well, think of this like a scale. Whatever we do to one side, we have to do to the other. It's got to be balanced. So we're going to add 147 and 67 hundredths to this side. So if we add this up, bring down our decimal point, we get 292 and 34 hundredths. So the only thing left on this side is our W. The only thing left on this side is our new answer of 292 and 34 hundredths. Well, let's double check to make sure. So we're going to come over here, we're going to check. We're going to plug this value back in for W. We're going to take 292 and 34 hundredths and we're going to subtract our 147 and 67 hundredths. A little bit of math to do here. Bring down our decimal point. Lo and behold, 144 and 67 hundredths, 144 and 67 hundredths. Looks like we got it right. So W does equal 292 and 34 hundredths. Let's do another example. Let's say 3m, or 3 times m, equals 16 and 8 tenths. Well, let's look at what our expression wants us to do. When a number or a constant is next to a variable with no sign between, it means to multiply. So what should we do? Well, we're going to divide. We're going to divide by 3, and that'll clear these terms out, therefore isolating our variable. Remember, this is a balance. This is a scale. So whatever we do to one side, we do to the other. So we're going to divide this side by 3. If you remember our rules for dividing decimals, we got to rewrite it in a bracket. 3 goes into 16 5 times, and it goes into 18 6 times. And then we move our decimal point straight up. So the only thing left over here is m. The only thing left on this side was the quotient of 5 and 6 tenths. Well, let's check just to make sure. So we're going to plug 5 and 6 tenths back in. So we're going to take 5 and 6 tenths, multiply that by 3. Got 1 spot there, 0 spots there, 1 in our answer. So 16 and 8 tenths, 16 and 8 tenths. Looks like we're good to go. That's the cool thing about this, is you can actually check your answers before you're done. So in this case, 5 and 6 tenths is the value for m. A couple more examples here. Let's do one with addition. Let's take f plus 4 and 2 tenths, and we'll say that that's going to equal 7 and 9 tenths. Well, let's look at our expression. What is this expression wanting us to do? Well, it wants us to add. So what are we going to do? Well, we're going to subtract 4 and 2 tenths. Those cancel out, isolating the variable. Whatever we do to one side, we have to do to the other. So let's subtract 4 and 2 tenths from this side. 3 and 7 tenths. So the only thing left over here is an f. The only thing left over here is 3 7/10. So f should equal 3 7/10. Let's check it. Let's take our 3 7/10 and let's add 4 2/10 to it. Decimal point. 7 9/10. 7 9/10. Looks like we're good to go. All right, one more example. Now we've done subtraction, we've done multiplication, we've done addition, so let's do some division. Let's say x divided by 4 1/10 is going to equal 3 6/10. Well, what is our expression wanting us to do? Well, it wants us to divide. So what do? Well, we're going to multiply. So we're going to take this whole side by 4 1/10. Cancels those terms out, isolating our variable. Well, whatever we do to one side, we do to the other. So we're going to multiply this side by 4 1/10. And that gets us, let's see, we got one spot there, so 2 spots in our answer, 1, 2. It gets us 14 76/100. The only thing left on this side is our x. The only thing left over here is 14 76/100. Well, let's go ahead and plug it back in. So it was division, so we're going to write it out as 14 76/100 divided by 4 1/10. Ooh, decimal in our divisor. So remember, we had to move that over one spot and then move that over one spot. Now, how many times will 41 go into 1? It won't. How many times will 41 go into 14? It won't. How many times will 41 go into 147? Well, that's actually going to be 3 times. Now, 3 times 41 is 123. And if we subtract those, we get a difference of 24. And now we bring down our 6. Now, how many times will 41 go into 246? Well, 40 goes into 246 times. That's 1 more, and then a factor of 6. I bet it's 6 times. So that's 246, difference of 0. Bring up our decimal point. So we got 3 6/10 and 3 6/10. Looks like we're ready to go. So x equals 14 76/100. So as you noticed, there's no difference between solving equations with whole numbers and solving equations with decimals, except for how you work that decimal with your operations in the standard algorithms. All right, hope that video helps, and good luck solving them on your own.